This is Mr. Ashton going through the PPE2 that we did, which is Maths Numeracy Unit 2, where a calculator will be required. Okay then, so first question. Now there's an awful lot of writing here. It wasn't really asking you to do that much, but it's important you read it and try and work out what it is asking you to do. So it says the head teacher of a school Borough Gwyn investigates a new bike shed. Bike sheds are built on a rectangular base of width x meters and length y meters. If you wanted to, you could try to even draw like a rectangle and then start putting that information in. But read the question first and check what it's asking you to do. So the head teacher is given a formula for working out the number of bikes B that can be stored in the bike shed, which has a base of width x and length of y. He is told that the formula only works when x and y are whole numbers. X is greater than 3 and y is greater than 5. The formula is as follows. And it says that B, number of bikes, is equal to 6xy, which means 6 times x times y, divided by 5. It says according to the head teacher, according to the details the head teacher has been given, what is the formula for calculating the length of y meters of a bike shed x meters y that can hold B bikes? So basically it just wants you to rearrange that and get y on its own. So the first thing I need to do is I need to take over this divide by 5, because the other stuff is like physically attach the y up on top. That's very easy to take over. That would give me 5b is equal to 6xy. Now, I want to get y by itself, so what I'm going to do is take this 6x, which is timesing by the y because they're touching, over to the other side to get 5b divided by 6x equals y, and I'm looking for that as one of my options, so 5b over 6y, so it's that one there. Okay, next page. It says the head teacher decides to place signs around the schools to stop pupils using their bikes on grassed areas. He introduces the new signs to pupils in the school letter. The size of the sign is as shown below. It says a mathematically similar new sign is placed near the side of the playing field. Now this word here, similar, is really, really important, and the way I've taught you is that you should know 3 formulas. One for length, one for area, and one for volume. And that is the small times by the scale factor will equal the big for length. The small times by the scale factor squared give me the big area, and the small times by the scale factor cubed will give me the big volume. Okay. Now we're asked here that it says, so it gives us the original dimensions here and here, but it says how wide is this sign here. So what I need to do is I need to work out what the scale factor is, and you can see here I've got a length there and I have what we call a corresponding length. We're given the height of both. So I can say the small one, 2.1, multiplied by the scale factor. Scale factor, because we're working lengths here, just straight lines, is equal to the big one, is equal to 33.6. I'm then going to take this times by 2.1 over, which will become divide. So the scale factor equals 33.6 divided by 2.1. The scale factor is, and that goes into my calculator, so 33.6 divided by 2.1 gives me an answer of 16. So basically, I'm timesing this one by 16, and I'll be dividing this one by 16 to be going back. But that's just for length. Remember, for area, it would be scale factor squared. For volume, it would be scale factor cubed. So the width of the original sign is 2.6, so I need to do 2.6 times by 16 to find out what the length, or what the width of that would be. So 2.6 times 16 gives me an answer of 41.6. Next question. Question 2. The price of softwood changes each year. The price has increased 6% per annum. Per annum just means per year, so it's increased 6% every year for each of the last 5 years. Before this, the price had decreased by 2% per annum. Okay. 7 years ago, so look, 5 there, 7 here. 7 years ago, the price of softwood was £34 per metre cubed. Calculate the current price of softwood. So 7 years ago, it was £34 per metre cubed. And we know for each of the last 5 years, it's gone up. But there were 2 years before that it decreased. And they want you to try and use the decimal or the formula method to make this really, really quick. So if 7 years ago it was 34 quid, it then decreased by 2% per year. So we've multiplied that by, now I write it like this, 100% take away 2% to the power of 2, because it was for 2 years, 5 years to 7 years. There's 2 years that happened that decreased for. Now, here there's a number of different ways I can write that into my calculator. First of all, I could say that it is 98%, and I could actually go and put that into my calculator. I could also say that 98% means 98 over 100 squared, and that would give me exactly the same answer. I could even go and work out what 98 divided by 100 is to make things slightly easier yet again, which is 0.98. All of these will give exactly the same answer. Okay, so I'm going to do 34 times by, you don't really need it in brackets anymore. If I was to do the percent sign, I put a shift bracket. If I do the over 100 bit, I'll leave it as that now. Squared, that will give me the answer of what it was. So it is 32.6536. Now some people look at that and say, that's money, we have to round that. The answer is not yet, because we haven't finished. After it decreased by 2% per annum for 2 years, it then increased by 6%. So let's underline increase there. Those words were also important. It's increased. So now its new cost 32.6536, and then we would times it by 100% plus 6. And that would be to the power of 5, because it is 5 years, and it was going up 6% per year, per annum per year. So then that goes into my calculator. I'm going to try and maybe write it slightly nicer into my calculator, which would be 32.6536 times by, I'm going to say 106 over 100. It's the same thing though. Like I say, you could actually put that into your calculator. You could put in 1.06 if you're confident with decimals, and then to the power button 5 comes to 43.69788272. Now, if in doubt, always write the full number. If you're thinking, what do I round to? Just write the full number, because you're definitely going to be picking up marks for doing that. But money is always rounded to 2 decimal places. So rounding that to 2 decimal places, that will make that go up to 70. So it's £43.70. Okay, then next question. Number 3. It says, the length of the size of a small wire shown, so the length of the size of each small wire square is 3.3 centimetres. There we go. Hlinos considers the length of the diagonal of each small square. She says the height of the window guard is equal to 9.5 diagonals of the square. The width of the window is equal to 11 diagonals of the square. Okay, well that's something to be worrying about a little bit. That's all that information down there. It says calculate the length of the diagonal of the small square. Give your answer to 1 decimal place. Now, if we go back and look at this one here, they've even put us in here that we've got a right angle and we've got a diagonal here. So if I ignore that bit there, I've got a right angle triangle, but we're usually a bit more accustomed to seeing it like that. This is telling me to use Pythagorean theorem because I want to find all 3 sides. I want to find a missing side and not another angle. So that would be a squared plus b squared equals h squared, although there's a number of different formulas you can use that. A squared plus b squared equals c squared is very common. You could use x squared plus y squared equals z squared. It really doesn't matter. I've used h because h is the hypotenuse. Now I don't know what the hypotenuse is, so this formula is all good to go. But if I did know the hypotenuse, I would tweak it to being h squared minus one of these one squared equals the other one squared. So that's going to be 3.3 squared plus 3.3 squared equals h squared. So 3.3 squared plus 3.3 squared press equals, and I get, SD it, I get 21.78. Notice I'm trying to keep my equals in a nice straight line, just to make my answer really, really obvious to follow to someone who's marking it. Now I want to get rid of that squared, so I'm going to take that over to the other side, and it's going to become a square root. A very quick way of writing this into your calculator is to say square root, and it remembers the previous answer, press equals, and then SD it, and I get a really long number again. So that's 4.666904756. Now there's absolutely no need to do what I've just written. I'm just saying, if in doubt, write the whole thing out, but then try and read the question. It'll usually tell you, if it doesn't tell you, you can round it to 1 decimal place anyway. That's what I tend to, but just check what it says in the question. So round that to 1 decimal place is 4.7 centimetres. And I'll just put in brackets 1 dp. Okay, now the next thing it asks me is calculate the area of the window guard. So that's where this statement here is coming into play. So it says the height of the window guard is equal to 9.5 diagonals of the square. So this square here, you've got 9.5 of them going in. So we're basically going to get a rectangle, and we know that we have 9.5 lots of that diagonal there, but we've just worked that out. That's 9.5 lots of 4.7. The width is equal to 11 lots of that diagonal going across, so that would be 11 lots of 4.7. So to work out that as an area, the area would be equal to the base times by the height. And then looking at what I've just drawn on the other page, the base will be 11 lots of 4.7. So I'll put that in brackets, 11 times by 4.7. And then I want to multiply the height, which would be 9.5 times by 4.7. And that will go into my calculator. Times 9.5 times by 4.7, which comes to 2,308.405. Now that's it in the calculator, isn't it? It stops there. I wouldn't actually bother rounding that to anything because it's only 3 decimal places. It wasn't actually that much of a pain to write out, but you could round it to 1 decimal place. That wouldn't be an issue. But just check the question. It didn't tell me to round it. The last one was 1 decimal place, so I can understand why you might say it. It also said you must show all your working. Now I've just drawn that picture over here. It might be an idea just to have drawn it down by here as well, because it was all to do with this question. So I'd say 9.5 times by 4.7 again, and then the base would be 11 times by 4.7. Okay. Okay. Next question. Now this question was answered really badly in the PPE. And that's because it was quite confusing in terms of they gave you everything day by day and minute by minute. Now the key word for me is it says last week her average speed was 9.6 kilometers per hour, and all of this stuff is measured in minutes. And it's telling me the thing for the whole week, and this is day by day. I don't want to work out her average speed in kilometers per minute per day, then find an average of that lot, and then try and change that into hours. It'd be much better to go and find the total distance travelled in the week, the total time travelled in the week, turn that distance from minutes into hours, and then we can work out her speed in kilometers per hour for the entire week, like they did. Okay? One other thing to mention here is that it says, I will be assessed for the quality of my organisation and communication and accuracy in my writing. So that means that my writing has got to be reasonably neat, it's got to be easy for someone else to read. Also, I'm not expecting to have loads of calculations just dotted everywhere. You need to sort of try and say what you're doing. This doesn't mean writing an essay though, just say what you're doing and sort of show it. So for instance, I'm going to say total distance travelled in this week. Now because I'm organised with my communication, I think it's pretty obvious what I'm doing. And instead of just saying what the answer is, I'm going to show what I'm doing, okay? And it's really important for questions like this, you're actually showing where your numbers come from. Although it's a little bit tiresome, I do get 2 marks. That's 6 plus 2 means 8 marks in total. 6 for the maths, 2 for just doing this, okay? So although it's annoying, I would write down everything that you're doing, okay? Anything that goes into a calculator, show what you're doing. Okay. So I'm adding up all of those numbers, and I've got the following answer. I've got 31.2. Now don't just leave your answer 31.2 in an OCW question. Put what it is 31.2 kilometers. Now I'm going to find the total time taken, and again show what calculation it is you're doing. So it's 26 plus 31 plus 12 plus 35 plus 40 plus 14 plus 22. And again, I'm putting all of that into my calculator. I've pressed equals, and my answer comes to 180 minutes. Now they want it in kilometers per hour last week, so we need to turn that into hours, and that works out really nicely. We know that 60 minutes is in 1 hour, so I'm going to divide that by 60, and I'm going to say why. 60 mins equals 1 hour, which is equal to 3 hours. So her average speed this week equals, so speed is equal to distance divided by time. Triangle to help us. Speed is equal to distance divided by time. And that would be d over t, so that would be 31.2 kilometers divided by 3 hours, which would then give me kilometres per hour to compare fairly. And that goes into my calculator and comes out to being 10.4, and we say km/h to write kilometres per hour in shorthand abbreviation. Now, have I answered the question? It said to calculate her percentage improvement in her average speed from last week to this week. Now you need to know a formula for percentage change, okay? So percentage change is equal to the difference divided by the original and then times by 100, okay? So we need to go and work that out. So in this case, it's going to be the difference, so 10.4, take away 9.6, divide that by the original was 9.6, and then we times that by 100, okay? That's the formula that we need to use. So that's going into my calculator. 10.4, take 9.6, over 9.6, times by 100, comes out at being 8.3, but note the dot on the top, 8.3 reoccurring, and that'd be percentage. So then I can fill that in by there. Okay, so as long as you're sort of explaining where your steps are, you're putting units in, this all counts towards this OCW. Okay, and as far as I'm concerned, that's fine. I've done this. I might just sort of annotate a little bit of working and just saying I've learned this formula. And then I'm just sort of explaining where it's come from. I've learned this formula to find percentage change. But it's maybe a bit of overkill to do that. You maybe don't need to do it. Only if you have time at the end of the exam, maybe go back and sort of just little annotations here and there. But in terms of what I'm doing, all my working has been shown where it's come from, and I've used units throughout. You don't need to put KMs after every single one here, but the final one would be perfect. Part B. It says, the diagram of the cross-section of one part of her run is as shown. And then it says, calculate the angle of elevation of the road. Now you might be sitting here thinking, what on earth is an angle of elevation? There are two things. We have something called an angle of elevation and an angle of depression. Now an angle of elevation is one that's going up. But if you read part C, if you think I don't know what to do, read part C and what it says. It says, Gwenda runs on another section of uneven road from A to B. The rise in this section is 300 metres. The angle of elevation is 10 degrees. Now, if you looked at this thing here, where do you think the 10 degrees is going? Here or here? Well, I think it's pretty obvious, even though it's not drawn to scale, that 10 degrees one surely has to be that one. And that is correct, because the angle of elevation is the one that goes up. Okay, it gets increased, it's going up here. So it's basically me getting that line and elevating it going upwards. Okay, and that's what's happened here. That's the angle of elevation there. Now, I tend to call the missing angle theta. So to go and work out theta, first of all, I need to go and label my triangle. So this right angle points at the hypotenuse. This angle we think of as a cannon. Cannons shoot cannonballs. So my cannonball here, over here, is the opposite. And then this side is next to the angle, we call that the adjacent. I would now go and underline any sides I know or I want to know. I know 1,600, so I'm going to underline adj, and I know 200, so I'm going to underline op. I don't know the hypotenuse, and I'm not asked to find it. I'm asked to find an angle, so I don't underline it. I now write the word SOHCAHTOA. Within that word SOHCAHTOA, I cross out O's and A's because I've underlined them. So O's and A's are going, and there we have it. We have tan theta. Don't forget the theta, it's very important. Tan angle, cos angle, sine angle, and we use theta for shorthand of the angle, is equal to the opposite, so that's 200, divided by the adjacent, so that's 1,600. I'm then going to take the tan across, not the tan theta, just the tan across, and that becomes tan minus 1 of 200 over 1,600. And I will then put that into my calculator. Now I've got the answer there, 7.1, yeah, let's do 7.1 degrees to 1 decimal place. Now, notice here on my calculator I have a little d. I could possibly have my calculator in the wrong mode, Whereas all I've done is change it so it now has a little r up there, and I press equals and I get a bizarre answer, a really, really, really thin segment there. Can you see that? 0.12. Now, that's because it has got a little r there. You need to have your calculator throughout the entire exam to have a little d. If in doubt, the way you do that is you press shift and mode, and then you say 3 for deg, and that'll change it to a d. And when I press equals now, it goes back to being that normal answer. If in doubt, press shift 9, 3 equals, and it'll make your calculator like it was at the box, and it will have the d there. Part C, it says that Gwenda runs on this section. I've already read this bit, haven't I? So she runs another section of uneven road from A to B. The angle of elevation is 10, and it says calculate an estimate for how far she ran. Well, she ran from A to B. Now again, label up that triangle. It's a right angle triangle. We've got height, we've got op, and we've got edge. I'm going to underline the op because I know it. I'm going to underline the height because I want to know it. I want to know the distance from A to B. And I'm not going to underline edge because I don't know it this time. Okay, so again, the word Sokotoa gets written out. And I'm crossing out O's and H's. Now I could stop there if I wanted to because I've already double crossed out. But if I went through, look, neither of the other ones are double crossed out. So that stands for sine angle. So that's sine 10 is equal to the opposite, so 300 divided by the hypotenuse. What I need to do now is get the hypotenuse on its own. So I don't like it being divided by it, so I'm going to take it round to the other side to begin with. So I'm going to get hype, and this time a divide goes over and becomes a times. Times sine 10 is equal to 300. And then to work out what the hypotenuse is, I'm going to take the divide by sine 10 over, and I'm going to go and find out what the hypotenuse is. But that's something that goes into my calculator, and it comes out at being 1,727.6 meters. Okay, I'll just show you 300 divided by sine 10. Oh, just to show you on that, on my calculator, if I press equals there, it says syntax error. I didn't close the bracket off at the end. It's really important you do that. Close the bracket off there, and we get that answer that I just had. So 1,727.6 meters. But again, I've rounded, so I need to say to one decimal place. Now, it says my assumption. My assumption is that I have literally just run in a straight line. Okay, so running in a straight line. Running in a straight line. What is the impact of your assumption? Well, if I'm running in that straight line there and I'm not going up and down, if I'm going up and down, surely I'm walking more of I'm walking more distance than what is actually there in a straight line. So the impact of my assumption is that I have calculated a shorter distance than she actually ran. Okay then. Number 5. Part A of this I thought was quite nice. Part B I actually thought was rather nasty. Now we were asked to estimate the mean of this this sort of question here about the diameter of dust particles. To do that, you want to create 2 new columns. The first column is going to be called a midpoint column, which I'm going to try and squeeze in by here. And underneath midpoint columns, we are always shading out so we don't accidentally add it up, because you are going to add this one up. In fact, it tells you there's 20 of them. And you're going to add up another column, which we're going to create called midpoint times frequency. Now, the middle of 1 and 2 is 1.5. The middle of 2 and 4 is 3. The middle of 4 and 5 is 4.5. And the middle of 5 and 9 is 7. Okay, so don't just blindly go up in a pattern that you just assume you've worked it out. That's not the case here, okay? So they're all slightly different. Now I want to do 1.5 times 2, which is, we can even put a time sign in between those, which is, no, it's not 6, it's 3, isn't it? 3 times by 6, which is 18. 4.5 times 8, don't know, so 4.5 times 8 is 36. And then 7 times 8, which is 28. I now need to add up all of those as well. And again, I wouldn't bother risking doing this in your head. It's too easy to make a mistake here. Is 85. And then to work out an estimate for the mean, we would do the 85. It's always the midpoint times by frequency column divided by the frequency column. And that comes to following answer. There you go, 4.25. Okay, now the next question, if you read it carefully, and this is the key thing to this question, you have to read it carefully. If you read it carefully, it's not too bad, but if you don't read it carefully, you're going to get a little bit lost and think, what on earth is it asking me to do? It says, Rodri measures the diameters of another 25 particles. Now, he just did 20, now he's just done another 25. Rodri is told that the ratio of the dust particles with diameters less than 4 microns to those measured to diameters with greater than or equal to 4 microns is 7 to 8. Okay, so diameters less than 4 to those with diameters greater than or equal to 4 is 7 to 8. Now, let's work out what he currently has up in this table. So currently, now this isn't an OCW question, but I'm just writing it just more for my benefit to work out what's going on. Currently, we have got 20 particles, less than 4 would be the 2 and the 6. Greater than or equal to 4 would be the 4, less than or equal to D5, and then 5 up to 9, okay? So currently he's got 8 to 12. 8 here, and then 12 here, okay? So that's 20 in total. Then we're going to go to a ratio of 7 to 8 from there. It tells me that. Now, that is for 15 in total, isn't it? 7 and 8 would be if there were 15 particles in total. However, we haven't got 15 in total. We already had 20, and then we measured another 25. So the total that we want is actually going to be 45 in total, because of the 20 measured in here and the extra 25 we've done there. So what we need to do is to try and find a link between 15 to 45. What have we done to that? Well, we've tripled it. So that means I need to triple this ratio. So 7 tripled would be 21, 8 tripled would be 24. So that's what it should be. It should be this, because that would then cancel down to 7 to 8 in simplest form. Now, in terms of what I'm asked, it says, how many of the extra dust particles have a diameter of less than 4 microns? So we already had 8, and there should be 21. So we want to do 21, take away 8 to get 13 extra. But I thought that was quite a tricky question. I didn't like that question at all. Now, a couple of you got confused what this word cylindrical means. A cylindrical thing means something that's a cylinder. A cylinder is, well, it's like a coffee cup, I suppose. A sort of kitchen roll is a great example of what a cylinder is, okay? So it's a circle, and then it's just basically stretched out, okay? Now, in terms of my cylinder there, we're then told some information. We're told that the height is 2 microns. Now, I'm just going to say 2, not 2m, because that would mean 2 meters, but its height is 2, okay? Then we're told the circumference, so the whole distance around it, is 5 microns. Calculate the volume of this cell. See, he sees under the microscope. Give your answer to one significant figure. Okay, now we're actually told the formula for the volume of a prism, and that is a prism because it has a constant cross-section. So if I kept on slicing going down, I'd always see a circle. So volume of a prism is equal to area cross-section times by height, or times by length. It doesn't matter. I've called it height because mine's standing up. You can see here they call this length because it's sort of like being flipped over. Now, the area that I'm going to see is the area of a circle. And then times by the height, which is, well, we already know that's 2. They've told us the height is 2. The area of a circle is pi r squared. So then we want to times that by 2. So then we're looking through the question, we're looking for what the radius is, and we're not told it. We're told what the circumference is. Now, the formula for circumference, there's 2. There's pi is equal, circumference equal to pi times diameter, or we could say that circumference is equal to 2 pi r. Okay, but that's because 2 radiuses make a diameter. Both of those formulas are the same thing, they're just using different things like within the formula. Now, because I want to know what r is, I don't want to use that one there because it will tell me what the diameter is, so I'm not going to use that one. Now, in terms of this one, the circumference we know is 5, so I can say 5 is equal to 2 pi r. Now I want to get r by itself, and rather like question 1, that means I want to take away this 2 pi times in by the r. So I'm taking that over to the other side where it will become divide because it's currently times by the r. So I know the radius is equal to 5 over 2 pi. I'm then subbing it into this statement here to find the volume. So the volume is equal to pi. We change the r to open brackets, the squared would come outside, and then we want to times that by 2, and r is the same thing as writing 5 over 2 pi. That's going into my calculator. So pi, bracket, fraction button, not 0 pi, I should just say pi, and then 2 pi on the bottom, and then 5 up on the top. Close your bracket squared, and then we want to double that answer, so times it by 2. And I get the answer 3.9788, blah, blah, blah. In the question, I've already underlined they wanted it correct to one significant figure. That is not 4.0. It's not me rounding that 9 up to being a 10 and then saying it's 4.0. It's actually putting the line down there after the first non-zero number. So that 9 would actually round that up to a 4 to one significant figure. So the answer is 4. Okay? Okay, question 6 is about stratified sampling. This formula very similar to working out a percentage. So the percentage formula is what you had divided by the total and then times by 100, and that turns it into a percentage. But we don't want a percentage. If you read the question, it says that this hospital here has made some changes to their patient care. They've got a number of doctors, a number of nurses, a number of management, a number of clerical, and they want to survey 75 staff. Using stratified sampling method, calculate the number of staff from each job. Okay, so the first thing we need to do is we need to work out the total. Now, you wouldn't necessarily need to go and show 120, add 320, add 56, add 144, because it's not an OCW question. You can if you want, but it's sort of like a little bit overkill. I'm going to anyway, just because I did it earlier and it's not really that much of an issue. And it's never really a bad idea to show in an exam question where your numbers are coming from. So putting that through the calculator comes to 640. Okay, so the 640 staff in total. So for the doctors, to work out how many doctors there should be, you do 120 divided by the total, and then you times by the number in the staff. Okay, the number of staff. So 120 over 640 times by 75. Now that comes out to a rank number, which we SD, and we get, and you need to write down the whole number here. We need to do a little bit of logic in a second, okay? 14.0625. Now, if I just calculate on, or if I just work on writing these out before sticking them all through the calculator, I can maybe save myself a load of work here. The nurses then would be 320 over 640 times by 75. The management, so I'll just say that's man, is 56 divided by 640 times by 75. And then finally the clerical would be 144 over 640 times by 75. Now, if you use your calculator, don't press on whatever you do because it will delete your memory. Try and use AC if you're going to clear anything, but all I want to do is use the replay button to come back and change the 120 to 320. So delete the 1, change it to a 3, and I've worked out there should be 37 and a half nurses. Then I'm going to change it to 56, so deleting all of that up on top, comes to 6.5625, and then this one here comes to 144, and SD it gives me 16.875. Now, we need to do a bit of logic here. We need to go and change all of these numbers. We obviously can't get 37 and a half nurses. We need to either choose 37 or 38. And logic would dictate that we choose 14 from there because we'd round that to the nearest number, which is 14, change that to 38, change that to 7, and change that to 17. But the one thing I will say, only one of those things stayed the same, not rounded down, but stayed the same, but 3 went up. You need to check these numbers add up to 75 because they may not. So 14, add 38, add 7, add 17 comes to 76, okay? So what we need to do is choose one of them to take off. Now, there's a couple of different ways to do it. You can use a bit of logic here. You can say there's the most people there are nurses, and nurses should have the most, and the least people are management, so management should have one taken off. That's one logical way of doing it. Another logical way of doing it is to say, well, we've got 0.5 here, we've got 0.5625, and we've got 0.875. So if I was to choose one of those to stay the same, that's got the least, and they've already got loads in anyway. So let's change the nearests and let's not actually round them up. So let's change them to 37. And now I've made that logical thing there, I'm going to go and change all of those there. So 14, 37, 7 and 17. Okay, the next question is one on random sampling, and they've given us a set of numbers here. Now, we know we have 120 doctors. It says use the following list of random numbers to select the first 5 doctors. You must start with the first number in the list, explaining clearly how you are using the numbers selected in the sample. Now, this bit is key, because lots of you did not do that in the PPE. Okay, if it says you must explain, then you must explain. Now, the way I'm going to do this is I'm going to label doctors in alphabetical order. Doctor A would be 001, all the way to Dr. Z being 120. Okay? Then I will choose only numbers in sample that include or contain 001 to 120. So the first number here, 032, okay, and then I'm going to say in brackets left to right, because I could go down, but I think it makes more sense to go left to right, as that's the way we read on a page. Let's choose those. So I've got 032, but he is bigger than 120, so I don't choose him. Excellent, 021, that's another one. 924, 152, loads of these not going. Ah, there's our third one. No, these are all too big. In fact, the whole line of that was too big, and all of this line. Now, there we go again, but look, take a second. We've already chosen 32, he can't come up again, so we can't choose him. Again, so none of those, but number 55 we can, so that's 1, 2, 3, 4 now, so we're looking for one more. There he is, because we're going up to 120, okay? So, doctors numbered 032, 021, 081, 055 and 105 are chosen. Okay, and that's how we would do that. Okay then, number 4, for population density, you need to know a formula. Okay, I've read the word population density already. Now we can use like a speed, distance, time triangle here. And our population density is going to go down there, and that is equal to the population divided by the area. Okay, but there's also another sting in the tail here. It says the population of the UK is 6.5 times 10 to the power 7. Correct the nearest million. Okay, and it says the area of the UK is 244,000. Correct the nearest 1,000 kilometers squared. Now, the best advice I can give you is to go and work out what half of this is, and then we'll find upper and lower bounds on each. That's what this to the nearest bit is telling me. So half of a million is 500,000, and then half of 1,000 is equal to 500. I would want you to go and find the upper and lower bound of each, regardless of what this says. Don't even read it yet. It's stuff we can do very, very easily. And also, let's take this out of standard form. That just seems silly. Now, we could potentially just put that into a calculator. Let me see if it tells me. 6.5 times 10 to the 7. Lovely, it actually tells you what it is. But if I had, say, to the 17, it just tells me it's the same there. And the way that we did that in class was that we took off, because there's one number after the decimal, we took 1 off the power. So that was 6. So that told me it was 65 with 6 zeros. 1, 2, 3, 4, 5, 6. But because I just put it into my calculator, I could even find that out anyway. Okay. Now commas come in the third back from a decimal point. So there's a decimal point. So third back and from a decimal point. Now that's what the population of the UK is. 65 million. That's what that was saying. So the upper bound of the population would be 65 million, then add half a million. So 65,500,000. And the lower bound would be 64,500,000. Okay, now the chances are you'll get a mark for writing either one of those. And then we want to do exactly the same with the area. So area, so I'll say population here, pop, and then area. And then the area we know is 244,000 kilometres squared. And we want to take away 500 and add on 500. So the upper bound, I'll add it on. So 244,500 kilometres squared. And the lower bound is what is it? Let me just chuck that into the calculator. I don't want to go wrong. 244, and then take away 500. And it's obviously 243,500. It's not worth the risk though, is that you've got a calculator, just use it if needs be. Okay? Now, it says, use these figures to calculate the greatest possible value of population density. Okay, so you want the number to be the biggest as possible. So we're either going to do upper bound of population divided by the lower bound of that, or vice versa. Okay, so I'd recommend doing both and then highlighting which answer we want. So using population density is equal to population over area. I'm going to say pop density is equal to, and I'm going to do the upper bound here divided by the lowest bound here. And then I'm also going to do the lower bound here divided by the upper bound here. So you sort of do it like the opposite way round. So you don't do both uppers, don't do both those, you do one of each. And then we will work out the population densities, and then we'll work out which one it is that has the biggest one. Okay, so we've got 6,500, and then 1, 2, 3, over 243,500. And that comes to 269.0 to 1 decimal place, whereas this one here comes to, so if I change that then to a 4, change that to a 4, I'll get 263.8 to 1 decimal place. So which one is the biggest? Well, this is my biggest answer here, isn't it? Now think for a second why that makes sense. That is the biggest population, the most people it could have been, in the smallest possible place. So that means that we've got more people per square kilometre. That's what it's really telling me. But you'll pick up marks. You'll get a mark for writing that one there and that one there. You won't lose marks for writing these ones here. You'll then get a mark for dividing them, and then you'll get a mark for choosing that one. But clearly make sure it's that one. So I'm going to put a line to that so someone can't think, you didn't mean that one there. Okay? Okay then, question 8. What's it asking me? A confectionery company is designing a new chocolate-covered base biscuit in the shape of a square-based pyramid. It then says the centre of the square base is labelled O. Each biscuit will have sides 3.4 and vertical height 2.1. Calculate the angle that one of the triangular faces makes to the base of the pyramid. Now, this has sort of already been tested on here. It's sort of getting me to work out what this angle here is. Now, in terms of doing that angle there, this is opposite that angle, so I want to use that. And this is adjacent to that angle, so I want to use that because I know it. But just be careful, it's not really 3.4, is it? 3.4 would be this entire distance. That's clearly in the centre, so we'd halve that number to get 1.7. And that's the hypotenuse, which I don't know. So again, writing SOHCAHTOA. And then crossing out O's and A's. That tells you use TOA. So that is tan angles. Tan theta is equal to the opposite, which is 2.1. Divided by the adjacent, which is not 3.4, it's 1.7, because that's half of 3.4. Take tan over to the other side, so we get tan minus 1 of 2.1 over 1.7. Again, make sure you've got a little d in your calculator. I can see it. You may not be able to, but trust me, it's there. And then that's 1.7. Now, strictly speaking, I should put a bracket around that at the end, but if you don't do it, like if I did like 1 divided by tan minus 1 of 2.1 over 1.7, it's going to kick off, but it doesn't really mind if it's not there on one of these ones. So tan to the minus with that, without the bracket, you get away with it. But I should really put a bracket around it. So can you see there that my answer is 51.0 to 1 decimal place. Okay, it says the company knows that that it costs 0.08p per centimetre squared to apply a chocolate covering. Calculate the cost of applying a chocolate covering to all 5 faces of the biscuit. So the best advice I can give you here is to actually try and think what that would look like if it was flat packed. So we've got this 3.4 square here, haven't we, at the base, and then we've got triangles that have all been by the side here that you want to go and work out, well, that they're all going to fall down like that. So I need to work out the area of a triangle. So the area of a triangle, is equal to base times height divided by 2. Now that triangle there, we know it has a base of 3.4, but what we don't know is we don't know what its height is, and the height makes a right angle with the base and goes right to the tip. The height is actually the hypotenuse of that triangle there. Now I know two sides, I want to go and know the third side there. So I need to go and do Pythagoras' theorem to work out the height of a triangle. So that's going to be a squared plus b squared equals h squared. So that's going to be the adjacent, which we said was not 3.4, was 1.7. So it's 1.7 squared plus plus this thing here, b squared. So that's going to be 2.1 squared, and that will be equal to h squared. That bit's going into my calculator. 1.7 squared plus 2.1 squared to get 7.3. Dead on is equal to h squared. And then I'm going to square root that answer. So say square root and I get a horrible number. Now, do not round that because we are not finished. If in doubt, write it to a couple of decimal places and then stop. But ideally, you're not going to round it at all. Okay? So therefore, area triangle is equal to the base. So the base of a triangle is 3.4, times by the height, which we just worked out, so it's 2.7 blah blah blah, all divided by 2, which is equal to, the area is equal to 3.4 times by, and, now I want the whole thing, so yeah, I need to go and delete that now, 3.4 times by ands over 2. And that gives me the answer 4.59 blah blah blah. Now again, do not round because that's the area of one triangle. I've actually got 4 triangles there, so I now need to times that by 4. So total triangles or all triangles. So answer times by 4 comes to 18.37. Yeah, I'm going to say 18.37 to 2 decimal places, but you could work 1 decimal place there, that's fine. I can stop now because that's found the area of all of the triangles. The area of the square, is equal to 3.4 squared, or 3.4 times 3.4. 3.4 squared comes to 11.56 centimetres squared. So the total area, is going to be 18.37 plus that 11.56, which comes to 29.93. This is hard. This is a hard question. You should find this tricky. Now, we know that it costs 0.08 pence per centimetre squared, and we've got 29.93 pence in total. So what we need to do is we need to, if it costs 0.08 pence per centimetre squared, we need to do 29.93 times by 0.08, and that's going to tell me how much the chocolate is going to cost, but in pence, okay, not in pounds. So that answer then, I am doing answer times by 0.08, and I get 2.3944 pence. Okay?